out of these three camera types, which one doesn't belong? Camera 1, this black camera. Camera 2, this silver camera. Or camera 3, this phone camera.
Well, while different arguments could definitely be made, this camera type does not belong because it's a film camera, and it captures photos by developing light that struck the film inside the camera. These two, on the other hand, are digital cameras, and are a little more complex in terms of how they function compared to this camera, which is what we're going to be talking about today, how digital cameras work. In order to fully understand how they function, we'll describe the basics of cameras and how specific parts of digital cameras work and interact with each other in order to take, create, and display a photo. Additionally, even while digital cameras are responsible for taking trillions of photos every year, more high-end digital cameras can produce photos like this, or something like this. There still are optimizations and potential ideas we have that can be integrated into digital cameras that can make these photos look even better.
Before you can learn about the specific features and the future of cameras, you first need to know the basics of cameras and what makes digital cameras unique compared to other cameras. Cameras are used to capture still or moving images, which are stored in a physical medium, such as in a digital system or on a photographic film. A digital camera is made up of two basic parts, the lens and the body. A camera lens takes all of the light rays around and uses the lens to redirect them to a single point, the subject, creating an image. According to a camera company called Canon, lenses work similarly to the human eye and allows for control of the amount of light that enters a camera. Inside each camera is a series of optical elements that work together to bend light and refract it into a single point. This would be the subject that one is taking their picture of. The lenses also have to focus on the subject. Focusing on something is done inside the lens by moving one or more lens elements closer to or further away from the image sensor. This changes how the lens refracts the light. To capture an image, you have to use the shutter button. The shutter button is that little circle at the bottom of your phone screen and that tiny circle on the top of your camera. A shutter button has two curtains that open to let light reach the image sensor and then close at the specified exposure time. In order to capture the image, the light entering through the lens strikes an image sensor. The signal output by the image sensor is produced within the camera to create image data, which is stored away on a memory card.
When all those light rays meet back together on a digital camera sensor or a piece of film, they create a sharp image. You've probably seen cameras like these. These cameras are called digital single-lens reflex cameras, also known as DSLR cameras. These cameras are commonly used in professional photography. Then there are phone cameras. Phone cameras are made up of only three basic parts: the lens, the sensor, and the software. The lens directs the light into the camera before the light reaches the image sensor. It passes through the small hole in the phone's body called the aperture, and the image capturing mechanism is the same. When light hits the sensor converts it into energy, and a computer built inside of the camera can tell how much energy is being produced. This helps determine what areas of the image are light and which ones are dark. Then, once this process is done, you can view their photo in their gallery.
Video cameras are devices that capture moving images and sound. They are similar to digital cameras in the fact that they use a sensor to capture light and convert it into digital information. However, video cameras are designed specifically for motion capture, and they often have features such as image stabilization, autofocus, and manual controls for exposure time. Video cameras can record in a variety of formats, including standard definition, high definition, and 4K. They can also record at different frame rates, which affects the smoothness of motion in the video. Some video cameras are designed for professional use, while others are more consumer-oriented. Professional video cameras often have interchangeable lenses, larger sensors, and more advanced features for controlling the exposure. Consumer video cameras are often smaller and more portable, and they may have built-in features such as Wi-Fi, image stabilization, and touchscreens. Overall, video cameras are specialized devices designed specifically for capturing motion, while digital cameras are more versatile and can be used for both still and moving images. The main difference between digital cameras and video cameras is the sensor and the storage. Video cameras use a sensor to capture the light and convert it into digital information, just like digital cameras. However, video cameras often have larger sensors than digital cameras, which allows them to capture more detail and color. Video cameras often have larger storage capacity than digital cameras, which is necessary for recording longer periods of time. Video cameras may also have built-in hard drives and memory cards, while digital cameras typically rely solely on memory cards.
Now that we know the basics of cameras, we have to understand how specific parts of these digital cameras contribute to the overarching function. Modern day digital cameras share the same basic parts which work together to capture and store photographs. A couple of these parts are the image sensor, the lens, the aperture, the shutter, viewfinder, the memory card slot, and the body and some important parts on it. So first, the image sensor captures light and converts it into an electrical signal that is then processed to form a digital image. Like we talked about before, the lens focuses light onto the camera's image sensor and takes all the rays bouncing around and uses glass to redirect them to a single point, creating a sharp image. When all of those light rays meet back together on a digital camera sensor or a piece of film, they create a sharp image. Aperture adjustments affect the depth of field for photos. The depth of field is the range between the nearest and the farthest objects in focus within a picture. Shallow depth of field, which blurs the background to help pop out the in-focus subject of the photo, is achieved with a wide aperture. On the other hand, a smaller aperture will give a larger depth of field, which allows someone to keep a larger amount of the frame in focus. This is ideal for group shots or scenic landscapes, compared to the shallow depth of field photos, which are great for portraits or food photography. Shutter is a device through which the lens aperture of a camera is open to admit light and thus expose the film, or in this case, the electronic image sensor of the digital camera. Adjustable shutters control exposure time, or the length of time during which light is emitted. And like we said before, the shutter is just this little button at the top that you basically click to take the picture, or the button at the bottom of your phone screen. An electric viewfinder is a small display that shows the scene in front of the camera. With an electronic viewfinder, you can see exactly what your sensor sees. This means that there is a live version of the image that's about to be shot. If the settings are changed, the exposure also changes on the viewfinder before the picture will be taken. A memory card is a kind of card that is put into a camera or a computer that is memory to hold digital files like photos, music, or documents. On the other hand, a SD card is a type of memory card popular with the majority of consumer camera manufacturers, used to store the photos taken with the camera, of course. A camera body is the main part of the digital camera, which contains the controls, LCD, and the internal image sensor, as well as all the associated circuitry. Basically, it includes every single component necessary to take the photograph. It is also the part of the camera that's held when taking the photo. According to DipRose, there are some very important features on the body of a camera. The built-in flash, more commonly known as a flash, emits a burst of light as soon as the photo is taken. It is mounted near the top of the camera and is used to light the whole area. The mode dial is also a very important part of this camera body. The mode dial decides what mode the camera is in, such as auto, or automatic, and manual. The main dial, on the other hand, is the dial on the front part of the camera that lets you adjust aperture, shutter speed, exposure compensation, and other functions. The lens mount is the last feature that is almost vital to the camera. Obviously, the lens mount is the place where the lens is mounted. hence the name. It is usually a kind of disc with 2 locking ports in it, so the lens will stay in place while taking the photo.
Moving on, one of the most integral components of a digital camera is the battery. But the current design of camera batteries leaves something to be desired, and it needs some improvement. But first, to explain how the battery is essential to a digital camera's function, think of flying a kite on a windy day. In this image, the wind itself would represent the battery, and each part of the kite represents a specific part of the camera. Maybe the string here stands for the lens, the body of the kite is the image sensor, the tail represents the shutter, etc. Obviously, the wind is necessary to make the kite fly, because without the wind, the parts simply wouldn't work together, or for that matter, they wouldn't work at all. This is just how a camera battery works. It provides the necessary energy to specific parts of the camera so that they can function. These parts include, but aren't limited to, the lens, flash, LCD screen, and the image sensor. According to Felix Richter, in 2017, 1.2 trillion digital photos were taken worldwide, which means the average person takes roughly 160 photos on a digital camera every year. All of this to say, despite digital cameras being used so much, after research we discovered there's still a flaw in digital cameras that affects the battery. Specifically, cold temperatures significantly limit the effectiveness of digital cameras by decreasing their battery life and efficiency. According to Jorn Peterson, quote, cameras, and especially the batteries, perform at less than full capacity in low temperatures. Batteries suffer in the cold because the chemical reaction that occurs to provide power is slowed down in colder temperatures, end quote. If the battery life were to be decreased, then the entire camera would feel the effects. Bringing it back to the kite model, it would kind of be like if the wind suddenly dropped in intensity, as this would cause the entire flight, the entire kite, to fly lower and not as high, and slower as well. This problem affects people drastically because a fun but cold day skiing in the mountains creates conditions where a digital camera's battery can't last the entire day to take pictures. Or a chilly night makes for less time to try to get a perfect shot of the stars above.
So how can we solve this? Our solution is to add more batteries with thermal insulation so the battery compartment is harder to lose heat. Because in cold temperatures, heat from the battery is transferred to the air outside. So if there were a thermal insulator surrounding the battery or integrated in the battery compartment, then this would be more resistant to the cold. By definition, a thermal insulator reduces the heat transfer between two objects. As for what type, a type of double wall insulation could replace the solid plastic structure surrounding the battery that's in use now. Double wall insulation is where a gas, which is a good insulator, is sealed between 2 layers of material. This method wouldn't require any extra insulative materials to be added, like cellulose, fiberglass, natural fibers, or steel wood, but just needs a gas like argon, and would make manufacturing much easier. Using what you already know about preventing heat loss and building off of the description we provided for the battery's function and implementation in digital cameras, what's an idea you have about this problem? Cameras being less efficient in the cold weather.
To conclude, take out your phones and examine its camera and try to explain to yourself how you can directly see what we've taught you in this speech. It is undeniable to neglect how much digital cameras will grow in the future. For example, Yahoo Finance predicts that by 2030, the digital photography market is expected to grow by roughly $50 billion, more than its evaluation right now. And it makes you wonder what the future holds for digital cameras. But as for right now, the basics of cameras and the way digital cameras work by using an image sensor to capture light traveling from the lens, let in by the shutter, and through the aperture is pretty concrete. And as we explained, our solution to batteries working less efficiency in cold weather ultimately helps the entire functioning of digital cameras. So bringing it back to the beginning of the speech, hopefully now you understood why this camera doesn't belong, as well as the crystal clear distinction between these. Even though digital cameras might have the same fundamental purpose as any other type of camera, Like any other type of camera type, both can be used to capture an image of a beautiful mountain range, a tranquil sunset, or a scenic beachfront view. What goes underneath the shell is what's notable. Thank you.